Welcome to the course Design of Reinforced Concrete Structures. In today's lectures, we are going to solve few problems on flanged beams. So, the first problem is, he has given a T beam, okay, and the dimensions, that is the cross-sectional dimensions, the grade of the concrete and the grade of the steel, everything are given in the question, and here he is asking to calculate the factored moment of resistance. That is, here what in this particular question we have to calculate the moment of resistance, that is mu. So first we will start with writing the given data. So here what is the flange beam? What type of beam is considered here? Here in the question he has considered a T beam. So let us draw a T beam. So a T beam of effective flange width. So what is the flange here in this beam? This is the flange. And what is the effective width of this particular flange? It is 1200 mm. And thickness of the slab is 100 mm. So what he has given? That is, he has given the depth of the flange. That is 100 mm. And the width of the rib is 300 mm. So the width of the rib or the web, anything is the same. How much it is given? It is given as 300 mm. And the effective depth of 560 mm. So what is the effective depth? The effective depth is here is 560 mm and it is reinforced with 5 number of 25 mm diameter bars. That is, you have how many number of bars here? You have 5 number of bars present here, and the effective depth D is how much it is given? The effective depth is given as 560 mm. So BF is given, which is 1200 mm. DF is given, which is 100 mm. Effective depth is given, which is 560 mm. The breadth of the is given, which is 300 mm. And how many number of bars we have? 5 number of bars. And the dia of each bar is how much? 5 number of bars, 25 mm. The dia of each bar is 25 mm. And what is asking to calculate here is asking to calculate the moment of resistance. And what are the grade of the materials used here? The grade of the concrete. FCK is M20. So FCK is here is how much? 20 Newton per mm square. And HYSD reinforcement of grade FE 4 and 5 is used. That is, FY is 415 Newton per mm square. And what is asking to calculate? He is asking to calculate the moment of resistance mu. So here you have to calculate mu, the moment of resistance. So first let us calculate the area of the steel reinforcement, that is AST. So how many number of bars are given? We have how many bars? 5 into 5. What is the dia of each bar? It is 25. Pi d square by 4, which will give you a value of 2455 mm square. So this is going to be the area of the steel. So the area of the steel is how much? It is 2455 mm square. Now in the previous lecture we have already seen what for a flange beam the neutral axis, it might either be in the web or it might either be in the flange. So here the position of the neutral axis or the neutral axis depth is not given. So the first thing what we have to do here is we have to find out whether the neutral axis is in the web position or it is in the flange position. So first what I am doing here is we are going to assume that the neutral axis is lying in the flange. So here what I am doing, I am assuming that neutral axis lies in the flange. That is, the neutral axis lying within the flange portion, and I am going to calculate the neutral axis depth XU. So in the previous session we have already seen the equations for calculating the neutral axis depth when the neutral axis lies in the flange. So how will we calculate? We will equate the forces of compression to the forces of tension. So what are the forces of compression? It is 0.36 FCK BF into XU will be equal to 0.87 Fy into AST. So substitute all the values here. See, 0.36 FCK. What is FCK? FCK is 20 into BF. BF is nothing but the effective width of the flange. It is given as 1200 into XU is what we have to calculate. Is equal to 0.87 Fy. What is Fy? Fy is 415 Newton per mm square into AST. AST is what we have calculated, which is 2455 mm square. So if you will solve this, you will get a value of XU as XU is equal to 102.59 mm. Okay, and we are assuming that the neutral axis is lying in the flange portion. We are getting a value of XU as 102.59 mm. So now what is the value of XU we have got? We have got it as 102.59 mm. Now if you see XU is greater than DF. Is it or not? So what is the value of XU? It is 102.59 mm. What is the value of DF? DF is 100 mm. So what does it mean? That the neutral axis is not lying in the flange portion. The neutral axis is lying in the web portion. That is, XU is greater than DF. That is what the assumption what we have done is wrong here. So what we have to do here? We have to find out the new neutral axis depth, that is the XU, based on the neutral axis lying in the web portion. So from this particular thing, what we have got to know that the neutral axis lies in the web portion. So the neutral axis where it is in the web portion. Now what we have to do? We have to calculate the new neutral axis depth XU, considering the neutral axis lying in the web portion. So what are the equation we have seen for calculating the new neutral axis? We have already known it. So what it is? We have to equate the forces of compression to the forces of the tension. So now let us equate the forces of compression to the forces of tension. So what is the forces of compression here? When the neutral axis is lying in the web, it will be 0.36 FCK BW into XU plus 0.45 FCK into BF minus BW into YF is equal to 0.87 Fy into AST. So this is the what? This is the forces in compression and these are the forces in the tension. So 0.36 FCK BW into XU plus 0.45 FCK BF minus BW into YF is equal to 0.87 FY into AST. So you already know how to calculate the YF. How you have to calculate the YF? YF is 0.15 XU plus 0.65 into BF. So this is the equation for calculating the YF. Now let us substitute all the values in this particular equation. So if you substitute the values, that is 0.36 into FCK. What is FCK here? It is 20 into BW. BW is nothing but the width of the web, 300 into XU is what you have to calculate, plus 0.45 into FCK. FCK here is 20 into BF. What is BF? BF is nothing but the effective width of the flange. It is how much here? It is 1200 minus BW. How much is BW? It is 300 into YF. How you can calculate YF? From this particular equation. So what it will be? It will be 0.15 into XU plus 0.65 into DF. What is DF here? DF here is 100 into 100 will be equal to 0.87. FY is 4 and 5 and AST is 2455 mm square. Now what you have to do? You have to solve this entire equation. So if you solve this entire equation, you will get the value of XU. The value of XU, what you will get here is XU is equal to 106.63 mm. So this is the neutral axis depth when the neutral axis is lying in the web portion. Okay, so the value how much you got, that is XU is equal to 106.63 mm. Now what? We have got the value of XU as how much? 106.63. So this is what? This is the new neutral axis depth, which is 106.63 mm. Now let us check for if YF is less than DF or not. So first let us find out the YF. So what is the formula for calculating YF? YF is 0.15 XU plus 0.65 into DF. So YF will be equal to 0.15 into XU. What is the value of XU? It is 106.63 plus 0.65 into DF here is 100. So from this you will get a value of YF which will be equal to 80.99 mm, which is less than the DF. So hence it is satisfied, that is XU value of 106.63 mm is acceptable. Now what we have to do next? We have to calculate the XU limit. So how will calculate the XU limit? So for the grade of steel, what is the grade of steel here? The grade of steel here is Fe 4 and 5. So it will be 0.48 into D. So if you substitute the value of D, you are going to get a value of XU limit as 268.8. So if you substitute the effective depth here, so you are going to get a value of XU limit as 268.8 mm. Now next what? You have to check for if XU limit is greater than XU is greater than DF or not. So what is the value of XU limit? It is 268.8 mm greater than XU. What is XU here? It is 106.63 greater than 100. Now that this is satisfying. So it is 268.8 mm is greater than 106.63. It is greater than 100 mm. Now what? We have two cases here. So what are the two cases here? One case is df by xu is less than or equal to 3 by 7, and the other case is df by xu is greater than 3 by 7. You have to check for these two cases, and that value, based on that value, we have to calculate the moment of resistance. So from this xu and xu limit value, what you can find out? That xu is less than xu limit. So if xu is less than xu limit, this type of section is called as an under reinforced section. Now what? We have to check for both these conditions, that is df by xu is less than or equal to 3 by 7 and df by xu is greater than 3 by 7. Now first let us check for df by xu, that is let us first find out the value of df by xu. So what? df, what is the value of df? It is 100 by xu. What is the value of xu? It is 106.63 mm. So if you calculate this, you will get a value of 0.93. So 0.93 is what? It is the value of df by xu. So now from this what we can say? We can say that df by xu is greater than 3 by 7. Why? Because the df by xu value is 0.93 and the value of 3 by 7 is 0.43. As 0.93 is more than 0.43. So the df by xu is greater than 3 by 7 is the condition what we have to consider here, and based on this condition we have to calculate the moment of resistance. So how we will calculate the moment of resistance based on this condition? We have already discussed in the previous class. So when df by xu is greater than 3 by 7, then in place of df we have to replace it with the yf. Yf is nothing but the equivalent depth of the flange. So what? We have already calculated the value of yf. So the value of yf is 80.99 mm. So in place of df we are going to substitute the yf and we are going to calculate the moment of resistance. So now let us calculate the moment of resistance. Now let us calculate the moment of resistance. So mu is equal to 0.36 FCK BW into xu. Here we have to consider xu only. Why? Because xu is less than xu limit, it is an under reinforced section, into d minus 0.42 xu plus 0.45 FCK into df minus bw into yf into d minus yf by 2. As the condition what we have got here, it is df by xu is greater than 3 by 7. So in place of df we have to substitute the yf. So substitute all the values what we have known here in this particular equation, so that we will get the moment of resistance. That is mu is equal to 0.36 into FCK. So what is FCK here? It is 20 into BW. What is BW? It is 300 into XU. What is the value of XU? It is 106.63 mm into D. What is D here? D here is 560 minus 0.42 into XU. What is the value of X2? It is 106.63 plus 0.45 into FCK. What is the value of FCK here? It is 20 into BF. What is BF here? BF is 1200 0 minus BW. What is BW here? It is 300 into YF. What is the value of YF you have calculated? It is 80.99 into D. What is the value of D here? D here is 560 minus 80.99 divided by 2. So if you will calculate this, you will get a value of mu is equal to 459.2 kilonewton meter. So the moment of resistance for that particular section is 459.2 kilonewton meter.